Okay, let's get started. Where is everybody? Where are all those people who are not sitting right behind you? Is there like a special at Menchie's that I don't know about? Okay, so we got 4 lectures on behavioral economics and public policy, and this is the second of them. And we're going to spend a chunk of the day, a chunk of the section, just sort of, a lot of it actually, just looking at these supply and demand diagrams and seeing how you can do a very similar kind of analysis on behavioral economic sort of market failures, behavioral market failures, as you can with usual classic market failure, externalities, and imperfect information, and so forth. Okay, so we're going to be talking about this thing that people refer to as an internality, right? So an externality is when there's a harm to, usually it's a harm, it could be a positive externality, but an internality is, a negative externality is when there's a harm to somebody other than the person who made the purchase, right? So I buy a car that burns gasoline, and there's harm from the pollution to somebody other than me. An internality, now usually, I usually write this word with quotes around it because it's not a technical term. It's sort of it's a loose term that we use. An internality, the way to think about it is, somebody buys a product or something, spends money on something, or makes a choice. It might be about spending time on something rather than money. And then there's a harm that falls on that person that isn't taken into account in their purchase decision or their time allocation decision. And then in terms of the sort of two-self model that we talked about, you can think about it as, say, for example, the beta self makes a decision about whether or not to go to the gym, and that causes a harm that accrues to the delta self. And so you can think of the internality being similar to an externality in that way. Now, I'm tending to put too many of these over here. There you go, cool for you guys. You can think about the internality that way. Now, that's a very loosey-goosey. That's not sort of technically, I don't want you to sort of, don't tell anybody else I said that, I guess is what I mean, because it's a very loose way of using the language, right? There aren't really 2 selves, there's only 1 self, and when it comes to doing policy analysis, what we care about is, harm to the individual, not to one or other of the individual's imaginary selves. Okay, so let's move forward. So let's just review, because we're going to be doing this kind of stuff, and I want you to really get what's going on here. Okay. So here's how you model attacks. Okay, so we know we set up a market, right? And we say here we're representing the decisions of consumers here, the decisions of producers here, and we have some equilibrium concept that tells us where the market will wind up. Okay, does anybody remember what the equilibrium concept is, or the equilibrium condition rather? The answer to my question is yes. You do know. You're not retrieving it. What must be true? What mathematical statement must be true? There's a word equals in the middle of it for a market to be in equilibrium. Supply equals demand. What does that mean? What does that mean? It is a technical condition. It's not just something we say. So the quantity demanded, right, is equal to some function, f of p, and the quantity supplied is equal to some other function, g of p. Okay, so the equilibrium must satisfy these 2 conditions. But of course, an equilibrium in this case is a pq pair. We have to have p and q to reach an equilibrium. We have 2 unknowns. We have 2 equations. We need a third equation to complete the system, and that equation is this: supply equals demand. Okay, it's not just some informal concept. It's a mathematical statement. Now we have. Sorry, why did I say that? 2 equations, 2 unknowns. 2 equations. What am I missing? Oh, that we're solving for a q. Yeah. So right. So this actually tells us that these 2 things have to be the same, right? We're solving for a particular point. Because you can imagine, it's not written in stone. If you were just creating a mathematical model out from scratch, you could say, oh, well, this will wind up at a point where the prices equal, the quantities aren't equal, and then you look at that and you'd say, that doesn't seem very economically feasible. What's more feasible is that we have a system that has to satisfy both of these simultaneously, and the equilibrium condition is this one. All right. That ain't going to change just because we impose a tax, right? So for a market to be in equilibrium under a tax, 2 things must be true. One is that equilibrium condition must still be satisfied. If you have a situation where producers are producing more than consumers consume, right? This is not economically feasible. If producers are just throwing stuff into the ocean, they would stop. And then the price to consumers must be greater than the price to firms by the amount of the tax. So that's just that mathematical statement. And you could, if you had a functional form for, if you had sort of like a minus bp and a c plus dp for here, you could then just say, okay, I need this to satisfy this equation and that equation and also this third equation simultaneously, and you'd be able to solve for the equilibrium quantity when the price paid by consumers is $t greater than the price received by producers. Does that all make sense? Okay, I'm going to run into not knowing names. 1, 2, 3, 4, 5th row up, 2nd seat in. You have a huge question mark on your forehead. No? You're cool? You got it? Okay. All right. Graphically, this is very straightforward. What do we do? What are we doing graphically to try to figure out a point where quantity supplied equals quantity demanded? What? You want it to be an intersection point, but that's the point where the prices also sit the same. And we're talking about it could be anywhere. The price doesn't have to be the same. The quantity has to be the same. The price doesn't have to be the same. That means we're going to be at a place where we're going to be in a place where the 2 points, one on the supply curve, one on the demand curve, are on the same vertical line, right? So for quantity supplied to be equal to quantity demanded, we have to be on some vertical line. And the question is, what vertical line? And it's going to be the vertical line. So vertical line satisfies this. And it needs to be the vertical line in which this is also satisfied, right? So it has to be the vertical line where PD minus PS is equal to T. In other words, a vertical line that cuts through these things in such a way that the distance between them is T, right? So what we do is we say, suppose T is this much. I don't know what that is in numbers because I don't have scale on this axis, but that's going to be T. So what I do is I just take this little line segment, right? I take that and I jam it in between supply and demand wherever it fits. That identifies a place where supply is equal to demand and the prices are different by T. Okay, so I would take that. I wish I had actually done it with animation, but it'll go in somewhere like that. And that's my equilibrium. Okay, so that's the quantity under the tax. That'll be the price that is paid on the demand side. This will be the price that is received on the supply side. Okay? Good? Claro? All right. Okay, so the tax, the way to think of this graphically is the tax drives a wedge between supply and demand. Now, you've probably seen, you probably learned this initially in Econ 1. The tax is, if the tax is borne by the consumers, then what you want to do is to shift the demand curve down. There's a problem with that. It's not a demand curve. If you think of this as shifting a demand curve down, you're setting yourself up for confusion. That's not a demand curve. That is the demand curve minus the tax. It doesn't actually represent any real thing in the world. What you're looking for is you're looking for a place where supply equals demand and the prices differ by T. And the way to capture that graphically in a way that will not cause you any confusion is like this. Okay? Then you do some welfare analysis, right? So let's see. I think. Right. So the welfare analysis is what? What's the deadweight loss in this? Anybody? How do we figure it out?
It's that triangle between the
it's that. How do you know? It's the suboptimal units in some sense. It's units that should have been produced because the marginal benefit is higher than the marginal cost, right? And so that is the difference between marginal benefit and marginal cost for the suboptimal units. That's the way I want you to do it first class and always. Great. What does it consist of? It consists of a chunk of lost consumer surplus and a chunk of lost producer surplus. Why don't I care about all of this? It's tax revenue. And to me, society is society is society. I don't care that I took it from you and gave it to someone else. All I care about is the sum total. Okay? That's because my name is not actually Dan Ackland. It's Dan Hicks-Holder. Okay? So that's the Hicks-Holder rule. We don't care who gets the money. All we care about is that it's still a member of society. If we took the money and poured it out and burned it, that would be a loss. Okay. That's how this is done. It's straightforward. This is not, by the way, the sort of logic of steps and the steps that we were just guided through is going to work for absolutely anything you want to model. So don't remember this as, here's how you do it for tax. Remember it as, these are the steps you always go through whenever you're modeling anything. Draw the model, figure out how to add into the model the thing that the government is going to do, or the internality or externality that you're modeling, and then just go through the steps. Where's the equilibrium? Where's optimal? What did you gain or lose? All right. Now, just for review, how do we model a negative consumption externality? So I'm going to do the risk to other drivers caused by driving a heavy vehicle. One of my weaknesses as an instructor is I find it very difficult to disguise my prejudices. I drive an extremely small vehicle, and it always makes me nervous when I'm around a big vehicle. I've also had friends who've gone from small vehicle driver to big vehicle driver. There's like this catastrophic plunge in their driving ability. I don't know what happens. Like suddenly people think that appropriate following distance is 6 feet. I don't know why. Don't let this happen to you. Okay, so what do we do? So we have risk caused to other drivers when you drive a heavy vehicle. Everybody see how that's an external, that's a negative consumption externality. You pay for a car, you pay extra for a big car, but that causes me harm because if we have a collision, you're going to kill me. I drove a Subaru Impreza into an SUV in 2010, and I was required to sign away. I had to sign a thing saying, no, I really don't want to get into this ambulance, and the people in the SUV were just like sitting there. So I was almost dead. They were not affected at all. So I can tell you from experience that this is a real externality. So what do? You have supply and demand for heavy vehicles, let's say. Okay? And, you've assumed that supply, right, so this is the marginal private cost of firms, and we're assuming away externalities in production. Now, that's probably not actually true for producing vehicles, but we're going to let that aside. The demand curve we're calling marginal private benefit because we're sort of assuming that there's perfect information about the benefits that the person buying the vehicle gets from the vehicle. We're not assuming that they don't understand the safety risks to themselves or that they don't understand how fun it's going to be to drive around in a heavy vehicle. But what we are doing is we're assuming that there's some other cost to society so that the demand curve isn't marginal private benefit, and we have to then model the marginal social benefit curve, which is the marginal private benefit minus the marginal external cost, MC sub E. Here we've assumed that that marginal external cost is the same. So for sort of every SUV on the road, the increase in risk to other people is the same. Or for every mile that is driven by an SUV, the risk to other drivers is the same. Okay? You identify dead weight loss the same way you always do. Okay? So we could walk through those steps, but there it is. It's this gray area. And then, after you've done that, go back and figure out who, like I said last time, there's a lot of times people learn how to do this, saying, first let's look at consumer surplus, then let's look at producer surplus, and then let's look at how they change. I claim that my way is a simpler and more reliable way to figure out the final answer. This is the dead weight loss. Then you want to back up and figure out what the impacts are on different groups of actors, right? So in this case, we would go back through again, and we would say, the cost, this externality, right, consists of a chunk of harm that is done to other drivers, right? So that's the marginal external cost times the suboptimal number of units, okay? Does that make sense? But then a chunk of that is consumer surplus that's earned by people driving the SUVs, and another chunk of it is profit that's earned by the makers of SUVs. So the net harm to society from this externality is the total external harm minus the yum-yums that accrue to the people who are in the market. So it's the external cost minus the benefit that is internal to the market. Yeah? Good? And now you have a story to tell. So you go through this sort of formulaic set of steps to identify to sort of figure out the actual answer, which is this great thing, and then you go back through and you can sort of pick it apart and tell a story. This is your crosstown taxi story about why the dead weight loss is what it is and who sort of is gaining and who's losing. Okay? Now what we can do is we can say, all right, remember last time I was talking about how this model, our models not only show us where markets can go wrong, but suggest what we might do to fix it. And the answer, of course, is you take a tax and you stick it in right there. You have a tax of that much. And if you had an estimate of the marginal additional risk to other drivers caused by each heavy vehicle on the road, you could say this is my best estimate in dollar terms of the dollar harm that other drivers experience because of this additional risk, and you'd say, great, that's how big we're going to make the tax. Okay, and that's how these models actually contribute to policy design. All right, fine. Right, and then what we've done, you can go through. What we would do is we would have gotten rid of what we would have done is effectively, you can reverse engineer it. We would have eliminated this chunk of harm at the cost of this chunk of consumer and producer surplus. So again, the benefit to society of that tax is eliminating this dead weight loss. And of course, there's this chunk of tax. Okay, and we say that's good for society. We say it's optimal. Notice that there's still an external harm being done. Right, there's still a bunch of SUVs on the road, or let's just say heavy vehicles, because this could be 18-wheelers, whatever. There's still a chunk of harm being done. So just to sort of finish the story about why we think this is the optimal policy, right? That's still external harm, right? And so there's still people out on the road that are suffering as a result of the drivers of heavy vehicles making their own self-interested choices. Why am I not bothered by that? Well, the answer is there's two possible answers. One is I should be bothered by it. The idea that Hicks and Calder came up with was this. Hey, look, here's this chunk of tax money. What we've done is that we've extracted this from the people doing the harm, and then, remember I said that I think I said this to you guys. Did I talk about the potential Pareto criterion? No, I didn't. Okay, I'm getting you guys confused with my graduate students. So what Hicks and Calder separately actually came up with was the idea that, this is not actually a Pareto improvement, but it is a potential Pareto improvement because you could take the tax money that you took away from the drivers and give it to the people who are actually experiencing the harm. Okay? You could take this tax money and ameliorate, right? Because that's exactly equal to the size of this, right? Those two things are the same size. So you can just take the tax revenue and go to the people, all the drivers of scooters, and say, look, this is money this is exactly the value that you need in order to be compensated for the risk that you're experiencing by people driving around in heavy vehicles. Okay? The fact that transfer never actually happens is sort of beside the point when we're doing policy analysis, but that's the sort of underlying idea.
So could you make the transfer by putting a subsidy on the scooters?
Well, so no, because so the question, because you could make that transfer by putting a subsidy on the scooters. Problem is then you motivate, that's yet another distortion. Now you're creating a distortion in the market for scooters as well. What you would want to do is to identify the scooter drivers and just give them a lump sum payment. It's tricky. It's very hard to do transfers like this without causing people's behavior to change. And as soon as you change people's behaviors by giving them an incentive to drive more scooters, right, you've tweaked the equilibrium in complicated ways. Oh, yeah, no, if our goal is just to say let's get people out of SUVs and on the scooters, then we should just tax the hell out of the SUVs and give huge subsidies to the scooters. What we're doing here, the idea is that there's some identifiable optimal balance between SUVs and scooters. So if we go and try to take that tax and transfer it over to the people who are experiencing harm by subsidizing the purchase of scooters, we're going to create yet another distortion, which is people are now going to want to buy more scooters. And that's going to change the equilibrium, and then that's no longer going to be the optimal tax. And it might be good public policy, but it's not what we're trying to achieve here. So let me come back to that idea. I'm going to come back to a similar idea later in the lecture. Okay. So again, I've made this claim before, I'll make it again. Analyzing irrationality market failures, so again, what we could call internalities, is no different from analyzing classical market failures, except for the following things, okay, with the following caveats. Without rationality, it's hard to know people's true value for goods. So if you go back here, we know the value to the drivers of these vehicles, because that's the height of the demand curve, and we can observe it in their market choices. Right? You can estimate the demand curve from observed price quantity data. And we can come up with an estimate of the marginal external cost caused by these people's behavior by going out and actually observing the increase in the number of accidents as a result of there being more heavy vehicles on the road, and then backing out of that the increase in probability of accident per driver, put a dollar value on the harm caused by having an accident. Boom, you've got your marginal external cost. Okay? When we're dealing with some sort of harm to yourself caused by an irrationality, it's hard to know people's true value for goods, okay, or anything, choices, activities, whatever it is that we're trying to focus on. Okay, this is the problem of, I say that, you tell me that your utility function is, u naught plus delta times u1 plus some, et cetera, and I say to you, actually, no, it's not. I know enough about you to know that it's actually this, right? The question is sort of how would I know this? I can't just go and get observed price quantity data, right? I can observe this. If I'm confident that that's the right model of your behavior, this is what your actual decisions are going to be based on, so I can observe that. The trouble is, in order to know how much harm you're causing yourself, what the internal cost to you of this sort of beta irrationality is, I need to be able to know what your true preferences would be if you didn't have that irrationality, right? And that's not something we can easily observe. So how do we estimate the size of the internality, the cost of people's mistakes? And then the other thing is that it isn't always clear whether people will think the government is making things better. Most people, when you show them this model of a Pigovian tax, right, they'll say, oh, external cost fixed it with the tax. Yeah, actually, I see the logic of that. Assuming that those if all of those assumptions in that model make sense, I can see that, particularly if you're not an SUV driver, you say, yeah, that makes perfect sense. I can see why that's a good idea. This is not always the case when you're correcting people's mistakes, when you go out to try to correct a sort of behavioral market failure. So, for example, the naive or projection biased consumers may very well think that their choices are already optimal, and it's maybe very hard to convince them otherwise. And then the other thing is that people just hate being told what to do, or even being sort of nudged in some direction or another. Now, just to sort of put this in perspective so you don't think that we're disappearing down a rabbit hole, it's also true that estimating size of external costs and benefits is very hard in a lot of situations. So the risk cost situation, I said, you could probably go get these numbers and do it, and probably someone has. But, there's this raging debate about what is the external cost of a ton of CO2 equivalent that gets released into the atmosphere. We don't know. That's very hard to put a number on. There's lots of other externalities that are also very hard to put a number on, and there are internalities, the costs that people impose on themselves through their irrationality, that, as I'll show you in a minute, we actually can potentially put a number on. So this isn't necessarily that different. And then the other thing is that, I was having a conversation with a student on the way back to my office on Tuesday. The fact that I can demonstrate to you scientifically or mathematically that your behavior is causing harm to some other person in a way that is not captured by the price you are required to pay for your car, your gasoline, or whatever it is, does not necessarily mean that you're going to thank me for taxing you, right? There are plenty of people who are no more interested in the benefits of others than they are interested in the benefits of their delta self. There's plenty of people who are, frankly, no more thrilled to be told what to do just because you happen to be able to demonstrate to them that there's an externality that accrues to other people. People just don't like being told what to do. So it's not obvious that the case of market failure from irrationality is necessarily so different than the case of market failure, of classical market failure. All right, now, let me show you an example. Smoking, this internality from smoking caused by present bias. Let me preface this. I just stumbled on this morning, and I haven't figured out exactly the best way to introduce this, but I'll just start up front. So, does anybody know about graphic warning labels on cigarettes? Is there anybody here from Canada? Canada. Cigarettes in Canada?